First installed by long-distance carriers for cross-country applications, optical fiber cable today is replacing copper and coax cable in local telephone networks, cable TV networks, local area networks, utilities, and even is used for intelligent transportation systems around the world. Leading the industry with the highest quality, most consistent glass fiber for these applications is Corning Incorporated, the company that invented low-loss optical fiber more than 25 years ago.
The optical fiber is really a very complex structure, a very remarkable structure. Many people think that it's simply a homogeneous strand of glass. In fact, it's not. It is multiple glasses. We have a central region that we call a core region that's a different glass composition than the surrounding material, which we call a cladding composition. But the whole structure is still glass. And it's the purity of that glass that allows the remarkable properties of the optical fiber to come about.
There are two basic types of fiber, single-mode fiber and multi-mode fiber. In single-mode fibers, the core is only 8 to 10 microns in diameter. Its small size allows only one mode or ray of light through at a time. Standard single-mode fiber is optimized for transmission at 1310 nanometers, and dispersion-shifted fiber is optimized for transmission at 1550 nanometers. This makes them suitable for applications ranging from local access, both analog and digital, to long-distance, high bitrate systems. In multi-mode fibers, the core is as much as half the size of the optical fiber. Several hundred modes of light travel through the core. The large cores of multi-mode fibers make them easy to connectorize and allow them to couple light from LEDs, VCSELs, and other inexpensive light sources. Multi-mode fibers are used in local area networks for emerging high data rate applications.
One of the things that had to be developed in this whole race to communicate with light was the precision manufacturing of the optical fiber.
Corning, the largest fiber manufacturer in the world, uses the latest generation manufacturing equipment and a systematic approach to product development to provide our customers with the highest quality optical fiber. Customers need a fiber that they can depend on. They want a fiber that has the performance characteristics that will allow them to future-proof their networks by installing fiber that can meet their current and future requirements. And they want a fiber that is easy to splice and handle. Corning manufactures all of its glass using an exclusive patented outside vapor deposition process. This means that all layers of the silica and other dopants used to make fiber are deposited in their purest form of vapor. Maintaining the purity of the raw materials ensures the strength and optical performance of the resulting fiber. Using quality systems, the process is carefully controlled to maintain the exact flow of each layer of the preform. Correct laydown of the raw materials builds quality into the fiber and ensures optimum performance in such areas as dispersion, attenuation, and fiber geometry. In the next step, consolidation, the soot preform is placed into a consolidation furnace. This high-temperature process transforms it into a solid, dense glass of remarkable clarity. The size of the preform determines the length of fiber that can be drawn from it. Over the years, Corning has enhanced the size of its preforms, improving overall quality and consistency. It is from this solid piece of glass that optical fiber is drawn. The preform is lowered into a furnace and the tip is heated, causing a gob of hot glass to descend. This is the beginning of an optical fiber. Once the initial gob has been removed, the fiber strand is threaded through a device that controls the speed of the draw. Throughout the draw process, associates work with online computer controls that monitor and control parameters. First, a laser measuring device monitors the fiber diameter hundreds of times per second. This data is transmitted to computer systems that make real-time adjustments that ensure the fiber remains within specifications as tight as plus or minus 1 micron. Next, the fiber receives a dual-layer acrylate coating. This provides mechanical protection for handling, cabling, and installation. After the coating cures, laser devices check the diameter of the coated fiber as it is wound onto large take-up spools and prepared for testing. First, every centimeter of fiber is proof tested to ensure its required strength. The fiber is then given to associates to verify optical and physical parameters. At measurement benches, a variety of tests are conducted to verify the fiber's performance against specifications. Parameters are measured either at 100% or are statistically sampled. To ensure ongoing fiber consistency, process equipment and measurement benches are calibrated and recertified against established specifications. Associates receive ongoing training and are recertified annually. Before they are shipped, all fiber reels are packed in a protective plastic spool cover, barcoded to track their mechanical and optical properties, and packed in recyclable shipping containers. The reels are then shipped to our customers from our automated warehouse.
In addition to the optical fiber, Corning has literally invented and then developed a whole family of ancillary components that are aimed at making our customers' optical fiber networks much more cost-effective.
Research, development, testing, and calibration take place at Corning's Sullivan Park facility and at the Center for Fiber Optic Testing, the most advanced fiber development facilities in the world. In Corning's Strength Lab, fiber strength is tested to assure its reliability after time and environmental exposures. Fiber coatings receive the same scrutiny. Here, a machine tests the strength of the coating material. Coatings may affect the fiber's handleability, both when it's first installed and if it is reconfigured. At the Center for Fiber Optic Testing, fibers are exposed to extreme environmental conditions to ensure that they will provide reliable performance to customers in their real-life applications. To that end, Corning also studies fibers' handleability. Here, we are looking at how fibers perform in mass fusion splices. At Corning, meeting customer requirements requires more than just quality products. It means having dedicated people who are committed to quality at every level of the organization, from manufacturing to customer service, to applications engineering, to sales support. It is this company-wide commitment that earned Corning the National Medal of Technology, the 1995 Malcolm Baldrige National Quality Award, and continued ISO 9001 certification.
We seem to have come so far in the optical fiber communication revolution, but in my view, we're just at the beginning. There's so many exciting things that are on the horizon.
Specify Corning, fiber you can count on.